Hello students, today I am taking now SN1 reaction students after finishing SN2 bimolecular nucleophilic substitution. Now I am taking unimolecular nucleophilic substitution reaction, unimolecular. Okay, so here students, as the name is suggesting, SN1 unimolecular, that means a single molecule is deciding the product. In the product formation, the contribution is of one molecule. Okay, that's why it is unimolecular nucleophilic substitution. First of all, I am telling you students that this SN1 involves formation of carbocation. I think you remember carbocation, it was very important topic in class 11th students. Carbon having incomplete octet with one positive charge is called carbocation. Okay, the organic species after the heterolytic cleavage, carbon is developing positive charge over it, is carbocation. So in SN1, carbocation is obtained. Here only I am telling you students, as you have studied that tertiary carbocation is having maximum stability. That's why that tertiary alkyl halide will be maximum reactive towards SN1. Here only I am telling you. Then we will take the mechanisms also. Here I am telling you students, this reaction again is taking place in two steps. Two steps meaning two reactants are there in this SN1 also, because Rx is there and one definitely nucleophile will approach towards it. It replaces the existing nucleophile and get attached over it. So there are two reactants, but again I am saying that the reaction will depend on the concentration of one only. How is it possible? Here I am telling you students, like if suppose we are taking any factory which is giving publication of any book, so that industry will be having different sections in it, like one will be the writing section, one will be the book binding section, one will be the paper cutting section, one will be the assembling of paper according to serial. Suppose all the sections are working very efficiently, but the book binding section is working very slowly. So all the section will get dependent over the binding section, because without binding, book will not come out in the market. So whichever section works slowly, all the sections will get dependent over that particular section. So we can say that that section which is working slowly is the rate determining section, or it will decide the publication or coming of book into the market. So here also the same thing is happening students. This I am telling you that two reactants are there. One is the alkyl halide and other definitely be the nucleophile. So here the reaction actually is taking place in two steps. If the reaction is taking place in more than one step, then the reaction is called complex reaction students. If the reaction is taking place in one step, like in case of SN2, the reaction is called elementary reaction. But here the reaction is taking place in two steps, and that's why we are calling that reaction as complex reaction. In the complex reaction, students, remember that rate of the reaction depends on the slowest step. If more than one steps are there, whichever be the slowest step, rate will be decided by that step only. So here how the reaction is taking place, friends, how the reaction is proceeding, that I am telling you. Firstly, the heterolytic cleavage is taking place, friends. Both of these shared pair of electron, this shared pair of electron is moving towards this X because X is having more electronegativity, and it is forming R positive and X negative, where R positive is carbocation. So in the first step, what is happening? Cleavage of this Rx bond is taking place. Okay. And the second step is now the formation of this R positive or the carbocation. Nucleophile is attacking over it and we are getting the final product. Here it is observed that this cleavage or the first reaction to form the carbocation is the slowest step, while the second step is the fast step. So as I am telling you that slowest step decide the rate of the reaction. Okay, so here I have written, students, rate of the reaction is decided by the slowest step. Okay, here I have written rate is directly proportional to the active mass of reactant of the slowest step. This square bracket, students, I am reminding you that shows active mass or the molar concentration in moles per liter. So according to law of mass action we studied in 11th class, rate of the reaction is directly proportional to the molar concentration or the active mass of the reactant at that time. Okay, so here rate is equal to K into Rx. K is the proportionality constant, velocity constant, rate constant. Okay, so now I think it is clear that rate of the reaction is decided by the slowest step. Here I have taken a genuine example for describing this SN1 reaction, students. As I am telling you that maximum is the stability of tertiary carbocation, that's why I have taken here tertiary alkyl halide. This is tertiary carbon, students, attached with 3 alkyl groups. So here this tertiary alkyl halide, when reacting with water, here water is acting like nucleophile. I told you, students, that any species which is having lone pair of electron over it acts like nucleophile. Okay, electron rich species. So here if these two are reacting together, we are getting this alcohol, tertiary alcohol, and HBr. Okay, students. So how this reaction is taking place actually? So again I am telling you the mechanism that firstly in the first step this reaction will take place in 2 steps, students. In the first step what is happening? Cleavage of Rx bond is taking place. If Rx bond is getting cleaved, what we are getting? We are getting this tertiary carbocation. So this cleavage is taking place here. Tertiary carbocation we are getting with this Br1 negative. This is the leaving group. Okay, leaving group, and this step is the slowest step, students. After the formation of this carbocation, readily this nucleophile water is attacking through its lone pair of electron over this carbocation. And what we are getting? We are getting tertiary. This is the intermediate, students, as you are observing that this positive charge is there on the oxygen atom. Here this oxygen is providing its lone pair of electron to this positive carbon, and it itself is developing this positive charge. Now since this product which we are getting is highly unstable, it is called intermediate step, intermediate product, transition product. Transition meaning in between final product and the reactant, whatever we are getting is called transition stage or transition product. This oxygen is highly electronegative, as you are knowing, is attracting the shared pair of electron from hydrogen side and eliminating out this H as H positive, and we are getting the final product which is tertiary alcohol. Okay, students, and H positive is eliminating out. So by this reaction we can say that reactivity or the maximum reactivity of tertiary alkyl halide will be there towards SN1. If reason is asked, what is the reason, students? Because tertiary carbocation possesses maximum stability. That's why it forms readily and proceed the reaction. While in case of SN2, students, we studied that primary alkyl halide is more reactive towards SN2. There, crowding effect was taking place. That reaction was not taking place in 2 steps. That was taking place in 1 step. SN2 is having elementary reaction, but SN1 is having complex reaction. Reaction taking place in more than 1 step. Here I have written one more thing, students, here. Like in SN1, the nucleophile can attack from any side, either from front side or from the back side. Like in the SN2 reaction, we studied that nucleophile always attack from the back side. But in case of SN1, nucleophile can attack from any side. Why, students? Because as we are getting this carbocation, it is acting like a magnet because positive charge is there over this, and nucleophile can attack to it from any side. Okay, so in SN1, nucleophile can attack from any side. So the probability of 2 isomers will be there either from front side or from the back side. And I'm telling you that in SN1, retention of configuration is taking place. Retention meaning configuration is not getting inverted as we observed in case of SN2, that the rotation was taking place by 180 degree. But here no inversion of configuration is taking place. Configuration remain like that only as in case of reactant. The nucleophile is getting added as such as the leaving group is leaving from the reactant. So retention of configuration is taking place. Stereochemistry is not getting changed here. So this is called retention of configuration. I will take a separate video, students, for describing you the optical isomerism, that is under stereoisomerism. What is, and in that I will tell you, students, what is retention of configuration and formation of racemic mixture. Everything I will tell you in that. Okay, so here in case of SN1, retention of configuration is taking place. Now I am telling you the factors which affects SN1 reaction. So what are the factors which affects this SN1 reaction, students? Firstly, the structure of reactant. In the structure, we have already done, students, that if the structure is tertiary, then it will show maximum reactivity towards SN1 reaction. Lesser in secondary, further less in primary, and least in case of methyl halides. Okay, so what is the reason, students? You are knowing, students, that since tertiary carbocation is having maximum stability. So firstly, the first factor which affects SN1 is structure of reactant. Here I have written in terms of phenyl also. If 3 phenyl groups are attached with this carbon, again it is called tertiary. So maximum is the reactivity towards SN1. Then secondary, lesser than tertiary. Then least in these 3 in case of primary. Okay, here, students, one more thing I am telling you. Mainly here SN1 reactivity is depending on the stabilization of that charge or the carbocation, we can say. So here I am telling you, students, that benzylic, students, in the previous video we did C6H5CH2 if group is there, that is called benzyl group. So benzylic group is having maximum reactivity towards SN1. Then allylic halides also I have given you the concept. Then comes tertiary, secondary, primary, and least in case of methyl halide. one more thing, friends, which is important. That is, if suppose alkyl halide is primary, but if it is having tertiary carbon on beta position, then also it will show SN1. I am giving you example so that you can able to understand it. Suppose here CS3, C, CS3, CH, CS3, and this is the compound strings where you are observing that X or the halide ion is attached with primary carbon, but its beta carbon, this is alpha, beta carbon is showing tertiary nature. Why tertiary? Three alkyl groups are attached to it. One alkyl group, second alkyl group, and this is the third alkyl group. So beta carbon is showing tertiary nature. That's why this shows reactivity towards SN1. SN1. If suppose I am taking one more example here, this again halogen is attached, halide ion is attached with 1 degree carbon atom. One alkyl group is attached with this carbon, two hydrogen are there. But it's beta carbon. Beta carbon, if you observe, friends, it is attached with four alkyl groups here. One alkyl group, two alkyl group, three alkyl group, and this is the fourth alkyl group. So this carbon is quaternary carbon, 4 degree I have written. That also give more reactivity towards SN1. So remember these cases also. Now, next I am taking is effect of solvent. As in case of SN2, we required aprotic solvent, but here for the stability of the carbocation, we require polar protic solvent, students. I am giving emphasis on this protic solvent, proton containing, proton giving solvent. So polar protic solvent is required in case of SN1 to stabilize carbocation. The next factor which affects SN1 is leaving group. Leaving group is same as in SN2, students. Bigger the size, more efficient will be the leaving group. So I negative, Br negative, Cl negative, and here this is F negative. Okay, so size is decreasing, and that's why here iodide ion is showing maximum probability of leaving, then Br, then Cl, and least in case of fluoride. Okay, students. So these are the factors which affects SN1 reaction. Now I am taking summary of SN1. So the summary of SN1 is, I am telling you lastly the points. We are taking the summation of all the points which we have done in SN1. It is a first order reaction. Product formation depends on the concentration of alkyl halide only, as we did. It proceeds in two steps. That means reaction is complex reaction. Carbocation is obtained as intermediate. And since 3 degree carbocation is most stable, so 3 degree alkyl halide shows maximum reactivity towards SN1. Okay, everything we have done, students. Next point is reaction is accelerated by polar protic solvent. Requirement of polar protic solvent is there in SN1, and in SN1 retention of configuration take place. Molecule symmetry is not getting rotated, so retention of configuration. So for today's students, this much is there. Now we will proceed with chemical properties of alkyl halide from the next class. Till then, thank you, students.